Today we will be solving for double integrals. So, double integrals sounds like it's a difficult topic. It's actually not that bad. It's as long as you know how to partially differentiate, it's not that bad. But the first problem that we're going to cover is the double integral of 0 to 1 and 0 to 1 from x squared plus y squared dx dy. Now, maybe you've been seeing this dx or dy this entire time, whatever variable you're integrating with respect to. But what this tells you is actually, well, whatever variable you're integrating with respect to. So, what does that mean? Well, just like how you can differentiate with respect to something, like you can differentiate x squared y with respect to, let's do the delta of the function. Delta x, you can differentiate with respect to x here. You can take the partial derivative of x, you can get this. Well, you can also partially, no one really calls it that apparently, but I'll call it partially integrate this. So, keep in mind, whatever order you integrate in doesn't matter. You can actually switch these bounds around and then switch this. So, well, both the bounds are the same, but you can actually just integrate with respect to y first, and then integrate with respect to x, and your answer will turn out to be the same. So the first thing we're going to do, we're going to integrate with respect to x. So we're going to write down the equation again. And what I like to do is just remove the other integral. It's a little distracting. The first thing we'll do is integrate with respect to x. Well, the integral of this with respect to x is x to the power 3, right? Just a simple integral here. But how about for y squared? Well, y squared is treated as a constant in this case because we're integrating with respect to x. So if y squared was a constant, let's say 2 here, well, your integral would be 2x, right? So the integral of this would be y squared times x from 0 to 1. And then all we have to do is plug in our numbers just for 1. It might help you to set these equal to your variable. So you can write down equals to x. So you know that you're only setting or substituting for x, not for y. So when you substitute 1 into x here, you get 1 cubed, which is just 1, over 3 plus y squared times 1, which is just y squared. And 0 just sets everything to 0. So this is our integral with respect to x. Now we can integrate with respect to y. So you set this integral again. We have 1/3 plus y squared dy. Now that we integrate with respect to y, 1/3 is a constant. So 1/3 turns to 1/3 times y. And y squared turns into y cubed over 3, integrating from the bound 0 to 1. Now at this point you don't really need to set equal to because you only have one variable, but I'll just set equal to y for consistency. Now that we've done that, all we have to do is just plug in our variables. So we have 1 here, so we set 1 here into our y, and we have 1 cubed plus, and then the rest just 0 out. So our answer is 2/3 for this integral. Let's do another one. So this time we're going to have different bounds, and I'll actually show you both the ways you can do it, and the order in which you do it does not matter. The order in which you integrate with respect to each variable. So I'll integrate with respect to y first. So in this case, I'm going to write down our y bounds. Oh, not dx. Now, here's the thing about this. When you're integrating with respect to y first, you need to put the y bounds first in the integral. You cannot put, you can't just switch these signs over and still have the same answer. You need to switch the bounds too. So if you want to switch dx dy instead, you need to turn it into this. which is what I'm actually going to do to show you that the answers will turn out to be the same. dx dy. So notice how my dx bounds 0 and 4, 0 and 4 are now at the front with respect to x as well. So let's solve. Let's just keep going on with this. Let's solve for the integral of 4x times y with respect to y. So the integral of this would just be 4x times y squared over 2 from 0 to 2. And this is technically the quote-unquote partial integral. So now we just have to input the numbers. We get 4x times 2 cubed squared over 2, which is just 2. And 0 just, 0 turns everything into 0. So our current integral is 8x. Now we integrate with respect to x. So we have 8x now, and we integrate with respect to x, and then you get 4x squared. We integrate from 0 to 4. And I'll set these equal to x for consistency. So all I have to do is just input the numbers. It's just calculus 1 now at this point. So we integrate, substitute the 4 into the x. This is 16, this is 64. So we get 64. And that is our integral here. Now, what if we do it this way first? What if we do it with this way first? Integrate with respect to x and then integrate with respect to y. Well, it turns out your answer will still be the same. So 0 to 4, 4xy dx is equal to 4y times x squared over 2, 0 to 4. Set these equal to x. And then we substitute x, 4 and 0 in. So if we substitute 4 and 0 in, we get 4 squared, which is 16, divided by 2, which is 8. So it's 8 times 4y, which is 32y. And 0 turns everything to 0. Now we have 32y. We can integrate with respect to y. So 32y dy is equal to 16y squared. Integrating from 0 to 2. So now that we've done that, we can input, or we can substitute our 2 in. So we substitute 2 in. This will give us 4, because 2 squared is 4, and 4 times 16 is 64. And notice how both our answers, 64 are the same. Now, for the next problem, we will be using the bounds 0 to 2 and 0 to 1 for the function y times e to the power of x of dy dx. So we're integrating with respect to y first. So let's remove the dx just to get a better look at this problem. And technically, there's another way that you can solve for these integrals. I'm just going to rewrite this because it looks better. But technically, since e to the power of x is treated as a constant, because e is a constant and y will be treated as a constant when you're integrating with respect to y, you could technically just take e to the power of x out of this integral to just get y. Maybe I should have showed you that at the beginning of the video. But this is another way you can do it that makes it significantly easier if you can't keep a bunch of numbers around your head. So we took out e to the power of x because it's a constant, and only when it's a multiple you can factor this out. Hopefully you know that. But we just set this equal. We get e to the power of x times the integral, this is the integral of y with respect to y of 2 to 0. Sorry. Set these bounds 2 and 0. And then this just equals e to the power of x times 2, which is just 2e to the power of x. Now we can integrate this with respect to x. 0 and 1, 2 ex of dx. Just the calculus 1 problem. And just like how you took out a constant, you can just take out the 2 here. Maybe it'll make things easier for you. And if we just integrate e to the power of x, it always equals e to the power of x itself. And these bounds are the x bounds. If we input 1 here, you get, oh, sorry, I need to multiply it by 2 still. If you input 1 and 0, you get 2 times e to the power of 1 minus 2 times e to the power of 0, which is just equal to 2e minus 2. So this is how you integrate with respect to x or y for double integrals. Now these double integrals can get a little more challenging when you switch into different coordinate systems. That's why I'm going to make videos about those. And also when you have to change bounds, because sometimes integrals are impossible to solve for, or not impossible, sometimes they're very, very difficult if you do it in a certain order. So I'm going to teach you how to switch the bounds as well in later videos. So if you have any questions, put it down in the comment section.